So we have an example for understanding what we studied for resistances, gate capacitance or junction capacitances, and obviously for our drain and source capacitances as well. So for that we need to solve this example. We can say that an example question. We have to create a switch model for MOSFET shown in figure. We have an MOSFET given here, which is which can be drawn something like this. We have this length as 3, and this one is also 3. We have this width as 5, and we have some other factors which are given as L bar is equal to 0.5 micrometer and L naught is equal to 0.05 micrometer, and we have VTN is equal to 0.6 volts. We have Kn is equal to 150 microampere per volt square. Then we have C oxide, which is given by 2.7 femtofarad per micrometer square, and I have another quantity, that is Cj is equal to 0.86 femtofarad per meter square, and the final quantity is CJSW, which is given by 0.24 femtofarad per micrometer square. So these quantities are also micrometers. This is also micrometer square. So first I have to find the value of length, because I have been given with the drawn and effective lengths. So the first thing is first we need to have L, that is given by L is equal to L bar minus 2 L naught, and this was equal to this L bar is equal to 0.5 minus 2 into 0.05. This turns out to be 0.4 micrometer. And then we have to find the linear resistance. For linear resistance we need some quantities, we have to find this linear resistance. This is given by linear resistance is Rn, which is equal to 1 over beta n VGSN minus VTN. So we have a value for VTN, and I think we have been missing with the value of VGS. So VGS is given as 3.3 volts, VGS. volts. So if we put the values here, हमारे पास अगर ये values put करें तो हमारे पास जो expression आती है वो है basically this beta n is equal to kn w by n. We have seen this formula earlier. This is given by kn bar into w by n. So we will put the values here for this expression. So हमारे पास जो values आएंगी वो हैं this is equal to 0.4 multiplied by 150 into 10 power minus 6, and then we have 3.3 minus 0.6. If we solve this expression, this Rn turns out to be 197.5 ohms. So इस तरह से आप अपनी जो ड्रेन जो बेसिकली लीनियर रेजिस्टेंस है वो फाइंड कर सकते हैं. So we have used the formula for the linear resistance. That should be kept in mind as well. So after this linear resistance, we have to find the gate capacitance. Gate capacitance is given by Cg, which is equal to C oxide into area of gate, and like we can say that area of gate is equal to C oxide into W into L bar, and this was given by like 2.7 multiplied by 5 and multiplied by 0.5. This is equal to like 6.75 femtofarad. So your gate capacitance is given by 6.75 femtofarad. So if we know the values of gate capacitance, what would be the value of CGD and CGS? These were given by half of the gate capacitance. So I can say that these were equal to 1 over 2 Cg, which are equal to 3.375 femtofarad. Then we have to find the junction capacitance. Formula for junction capacitance is Cn is equal to Cj a bottom plus Cj SW and P. If we solve this expression and we know the values of all these factors, this will be equal to so the junction capacitance comes out to be 16.98 femtofarad. So final drain source capacitances can be found by like Cs is equal to Cgs plus Csp, and CD is equal to CDS like CDG plus CDV, and we know that like CGS and CDG both are equal to like 1 over 2 CG, and CS like CS is equal to CD. We know that like these two capacitances are equal. If these two capacitances are equal and we know these two values of these two are also equal, then we can put the values here and we can find the values of CS or CD. So CS or CD is equal to 3.375 plus 16.98, which is equal to like CS CD is equal to 20.36 femtofarad. So if you are given by like a design model, you can solve the all these values here, like up resistance, capacitance और different values हैं वो easily find कर सकते हैं, obviously keeping in mind all the factors which we need from the geometry or obviously from the equations. So this was an example which shows how you can calculate the like resistance and capacitances of a model which is given as like in a geometric form. So this is it for this video. I will see you in next video inshallah.